Welcome back, students. In my previous lecture, that is in lecture 1, I have explained about comparison of digital and analog systems, advantages of digital systems over analog systems, limitations of digital techniques, and logic levels. In this video, I'll be explaining about the elements of digital logic. The images that I have used in all my lecture videos have been taken from the internet. Let us see the elements of digital logic. Logic gates are the fundamental building blocks of digital systems. There are 4 logic elements with which we can make a digital system. They are the basic gates and flip-flops. So by using basic gates and flip-flops, we can make any digital systems. A flip-flop itself can be constructed using gates. There are 3 basic gates. They are AND gate, OR gate, and NOT gate. AND gate, this is the symbol of AND gate. This is the logic symbol of AND gate. It is having 2 inputs. A and B are the inputs and 1 output. Y is the output. A and B are the inputs and Y is the output. This is the logic symbol of OR gate. It is having 2 inputs. A and B are the input and Y is the output. This is the NOT gate. NOT gate is having 1 input and 1 output. This is a NOT gate. So these are the 3 basic gates. In additional to these gates, there are 2 universal gates. They are NAND gate and NOR gate. Why are these gates called universal gates? Because any circuit can be constructed using only NAND gates or only NOR gates. Here, this is the logic symbol of NAND gate. It is having 2 inputs A and B and 1 output Z. This logic symbol you can notice here, without this bubble, it is the logic symbol of AND gate. So one AND gate with a bubble gives NAND gate and one OR gate with a bubble gives NOR gate. NOR gate is also having 2 inputs A and B and 1 output Q. There are 2 more gates in addition to these gates. They are XOR gate and XNOR gate. So this is the symbol of XOR gate and this is the symbol for XNOR gate. XOR gate with a bubble gives XNOR gate. These gates are also having 2 inputs A and B and 1 output. And these gates can be interconnected to perform a logic operation. For example, this is a logic design which performs the adder operation. In this logic design, we are using 2 AND gates, 1 OR gate and 2 XOR gates. So this interconnection of gates to perform variety of logical operations is called a logic design. We can do many operations by combining the logic gates and flip-flops. Some of the common operations are arithmetic operations, comparison, code conversion, encoding, decoding, multiplexing, demultiplexing, shifting, counting, and storing. All these will be explained in my later lectures. For time being, let us see the block diagram operation. The arithmetic operations are addition, subtraction, and multiplication. First of all, let us see the arithmetic operation addition. The addition is performed by a digital logic circuit called adder. So what is the function of the adder? The function of the adder is to add the addend and the argent with a carry input and generate a sum term and a carry output term. So you can see two block diagrams here. This is the block diagram for a half adder and this is the block diagram of a full adder. In this half adder, two inputs are given, A and B, and the half adder generates two output, sum and carry. In full adder, three inputs are given, that is addend, argent and a carry input, and the full adder generates two output, that is sum and carry. The next arithmetic operation is the subtraction, and the subtraction can be performed by a digital logic circuit called subtractor. So what is the function of the subtractor? The function of the subtractor is to subtract the subtrahend from the minuend, considering the borrow input and to generate a difference term and a borrow output term. Since subtraction is equivalent to addition of a negative number, it can be performed by using an adder. So this is the block diagram of a half subtractor and this is a block diagram of a full subtractor. In half subtractor, two inputs are used, A and B, and the half subtractor generates two outputs, difference and borrow. And in full subtractor, three inputs are used, that is a subtrahend, a minuend and the borrow input, and the full subtractor generates two outputs, that is difference and borrow. The next arithmetic operation is the multiplication. The multiplication can be performed by a digital logic circuit called the multiplier. So what is the function of the multiplier? The function of the multiplier is to multiply the multiplicand by the multiplier and generate the product term. So for example, here you can see a 2-bit binary multiplier. So these are the bits here, A1, A0, B1, B0, and it gives out the output P0, P1, P2, P3. So this is how the multiplication is done. A1, A0 into P1, B0. B0 into A0 is written here, A0, B0. B0 into A1 is written here, B0, A1. B1 into A0, B1, A0. B1 into A1, B1, A1. So these are the partial products. And finally, you will get what is P0. P0 is A0, B0. What is P1? Add up these two, B0, A1 plus B1, A0, which is written here. And P2 is B1, A1 plus carry out of P1. And P2 is carry out of P2. So here the multiplication involves a series of addition with shifts in the position of partial products. Therefore, this multiplication can be performed using adder. Next arithmetic operation is the division. Divider is the digital logic circuit to perform division. And the function of the division is to divide the dividend by the divisor and generate a quotient term and a remainder term. It involves a series of subtraction, comparison and shifts. Therefore, it can be performed by an adder. Now let us see the next operation, that is encoding. What is encoding? It is the process of converting a number or symbol to some coded form. Encoder is a digital device that receives digits like decimal, octal, etc. or alphabets or special symbols, and it converts them to their respective binary codes. Decoding is the inverse operation of encoding. A decoder converts binary coded information to outputs such as decimal digits, octal digits, etc. The figure shows the decoding of the binary to octal digit. Next operation is the multiplexing, and the digital circuit used for this multiplexing is a multiplexer. A multiplexer is also called a data selector. A multiplexer is a logic circuit that accepts several data inputs and sends one of those data input to the output. Therefore, it is called a several to one device. This figure shows a 4 to 1 multiplexer. The next operation is demultiplexing, and it is the inverse of multiplexing. Demultiplexing is the process of switching information from one input line to several output line. That is, it is 1 to n device or 1 to several device. So this figure shows a 1 to 4 demultiplexer. Next operation is comparison. Comparator is the logic circuit used to compare two quantities. For example, there are two quantities here, A and B. So what is the function of the comparator here? It will compare these two quantities A and B. That is, first it will check whether A is equal to B, or it will check whether A is greater than B, or whether A is less than B. So the job of the comparator is to check whether A is greater than B, or A is equal to B, or A is less than B. Next operation is the code conversion. A code converter is a logic circuit used to convert information coded in one form to another form. For example, this BCD code is converted to XS3 code. Next function is the storage. Registers are used to store and shift information. Registers are temporary storage device. They are made up of storage elements called flip-flops. Counting is the next operation, and counter is the logic circuit used to count the number of pulses. The pulses represent some events. Flip-flops are used to build counters. And all these logic functions are available in integrated circuit form, or in short IC. ICs are classified into digital and analog ICs. Several IC fabrication technologies are used to produce digital ICs. For example, microprocessor is an LSI or VLSI device that can be programmed to perform arithmetic and logic operations and other functions. With this, I conclude this topic here. In my next lecture, that is in lecture 3, I'll be explaining about the number system. Thank you.